Hey, hi everyone. Good morning.
Good morning.
Good morning.
All right. So yesterday we discussed about the data and we discussed about various aspects of data. We talked about structured data, semi-structured data, unstructured data. Then we also touched upon the different uh, kind of uh, things which we relate to the big data, like volume, velocity, variety, and veracity. So anybody has any questions on those areas, please let me know. Otherwise, we will continue with this data in today's class also. So here we are going, today's class, we will cover some of the features about the data. Okay, and these features are important when you are dealing with any kind of analytics solution. You need to understand basically the attributes about the data what you're handling. And if you understand these features and these attributes of the data, you can able to collect the right data which could be useful for your analysis. The first thing comes is the entity. So when you are capturing the data, you have to make sure that for which entity you are collecting the data. Is it unique or are you mixing multiple entities together? Okay, so that is important. So entity as a definition, it is a thing that exists about which we research and predict in data science. So firstly, when you are transforming your or translating your business problem into an analytical problem, you have to identify about which you want to you want to do your research about which thing you want to make certain analysis for. Okay, and then in that case, you can able to identify which entity you need to consider. So this entity has a business context. Okay, so because you are solving a business problem, so definitely this entity will have a relevant business context. So for example, customer. Okay, if you want to do some kind of analysis related to customer, here the entity would be customer. So you cannot mix the customer and the vendor information together and do your analysis. So you have to be very specific what entity you want to consider to solve that business problem, and you have to collect the data related to that entity only. So if you are doing customer analysis, see that what kind of internal data you can use to perform a good customer analysis, and see that what kind of external sources also you can utilize to bring out some more insights about your customers. So be it like social media. From the Twitters, can you fetch some data, related to your customers? In that way, you will have a better context or better data related to the entity or about which you are doing your analysis. Second example is patient at a hospital. If the business problem is from life science and hospital sector, and if your analysis is in and around patients, then here the patients will become your entity. Okay. So here you need to understand the patient and the customer. Will it be the same in your context or will it be different? The same person can be a patient and can be a customer, but the business context to which you are performing that analysis may change. See, the patient can be outpatient, can be inpatient. So if you want to make analysis between the outpatient and inpatient, then you have to consider a different entity. Outpatient, because outpatient and inpatient both are your customers, right? When you're talking from the hospital perspective. So you have to be very sure, what kind of entity you have to consider for solving your problem and for doing your specific analysis. Okay. And now it's not something that always entity should be the living things. It could be a non-living things like car or a particular manufacturing plant or particular region, whatever, okay, or particular product. So you need to categorize what entity will be you have to use, it could be a collection of multiple entities also. For example, when you are talking about patient analysis, patient would be your broader category, but inside that the inpatient and outpatient can be your sub entities. Okay, so when in data science language people talk about entity, just understand it is the subject on which you have to do your analysis, about which you have to do your analysis. Okay, now comes the characteristics. So definitely now you take any kind of entity, be it like machines which you want to analyze, be it like customers what you want to analyze, be it like cars which you want to analyze, or patients you want to analyze. Every entity will have different kinds of characteristics through which by which they will become unique. So every entity will have a separate set of characteristics, and these are the unique properties. For example, for customers, okay, the demographic details like their age, income group, location, gender, education, all this will become a characteristics of that entities. If it is like machines, the model, the make, the size, all that could be the attributes or characteristics of the machines. For the car, this year, engine, make, model, okay, that could be the characteristics. So again, these characteristics will play a very important role when you are training or when you are building any predictive model. In the predictive model, the algorithm will try to understand, okay, if the customer is having these kind of characteristics, then basically they behave like this. If the patients are having these kind of characteristics, basically they will prone to have these kind of diseases. If the car is having these kind of characteristics, then the mileage or the reason for failure could be this. Okay, so these characteristics will play a very important role. So you have to look out for this kind of data also when you are considering any particular entity, and according to that particular entity, you have to look out for a relevant characteristics of those entities. Probably it may not be there in the same database or the same table. Then you have to look out specific different kinds of tables or different data sources, to pull out those kind of information. Okay, so is characteristics clear? For example, here the customer, the age, income group, gender, education. Every customer will have a different characteristics. They will have a different age. They will may fall into different income group. They may fall into different gender, education, right? So again, for the patient, age, blood pressure, weight, family history. Again, the characteristics would be unique, for every patient. Even for the car, based on the characteristics, it can be, uh, segregated. Now comes the environment. So now, what is environment? Environment plays a very important role in terms of understanding the behavior of the entity. So environment is nothing but it is an ecosystem in which that particular entity exists, okay, and functions. If you acquire information related to the environment at which that entity exists, it will give you again a different perspective. It will give additional information about that particular entity's behavior in that particular environment. So, for example, I'll tell you. So, for example, air condition is your entity, okay, and you, let's suppose you are a data scientist of that particular manufacturing company, okay, which manufactures that particular AC. Now, if you want to analyze the behavior of that air condition, okay, just the characteristics like the make, year, model, everything would not be enough. You also need to have information like where those ACs or those air conditions have been installed, because their performance, their behavior would also be impacted based on the environment, based on the location where they are installed. So, for example, if the AC is installed in residential houses, okay, the performance would be different. If those air conditions are being installed in industrial setup, the performance would be different. if those air conditions have been installed in some kind of shops, okay, their performance could be different. Because of the consumption, because of the external factors, their behavior could be different. So if I want to predict the machine failure model, okay, failure detection model, I cannot consider all the air conditions without, having any information about their environment in which they have been installed. If I don't consider that, my predictive model will not give me a clear picture. Okay. So I cannot able to detect, which machine is going to fail when, because I don't have any information about the environment. So sometimes the environment plays a very important role. And again, you have to look into that particular information also when you want to do particular analysis. So whatever I'm telling you now, these are different attributes of the data which you should start looking at, when you have to do some kind of overall analysis about the entity. So if you capture all that information about a particular entity, you can able to give the complete holistic picture about that entity's performance, and you can build even predictive models on top of it if you have all that information. Okay, so environment affects the entity's behavior. This is a very important point. For example, customer. So if and you will even agree, right? The person who is staying in Hyderabad will have a different behavior when compared to a person, who is staying in Delhi or in other northern part of the country. Because their preferences, their culture, their likings, their dislikes, okay, all that varies, with respect to region. So it is very important. I cannot consider all my customers as my same customers, okay? The South Indian customers may have a different likes. Okay, they may look out for different kinds of products, while the North Indian customers, they may look out for different kinds of products. So their behavior may change based on the region, right? So there, the country, the city, will play a very important role, in terms of understanding the customers. If you look at the data as a whole, you can able to understand that, okay, North Indian customers, they like these kind of products a lot because they buy these kind of products more often. While South Indian people, they buy these kind of products more often. So the country, the city, the location, okay, the environment at which that entity exists plays a very important role in terms of understanding the behavior of that particular entity. For example, patients now. So even the patients, their characteristics, their behavior, or uh, their health conditions also depend on the city and the climate. So, for example, the people who are staying in rural areas, their health conditions would be different than people staying in urban areas. Okay, the people who are staying in slums, okay, their health conditions would be different than people who are staying in, in gated community, right, who are rich. So even the climate plays an important role. The people who are staying in and around uh, any kind of thermal power plants or the mining or somewhere in the in nearby deserts and all those things, their health conditions would be different. While the people who are staying in a very extreme cold conditions, right? So their vitals, their health conditions would be different. So again, the environment here, when it comes to patient, it plays a very important role. So from where that patient has come, where he stays, what is his lifestyle and all those things. Even for the car, okay, if you want to analyze the car's behavior, like how much mileage it is giving, so it is important, where that car has been driven. Okay, whether it is driven inside the cities or on the highways. Okay, and again depends on the external factors also in the environment. Okay, so whether it is a terrain or whether it is a proper highway. Okay, so even the external or whether the climate, whether it is a cold or hot. Okay, all those are external factors which also impact the car behavior. So in and all, by now you would have understood that, okay, if you want to analyze any entity's behavior, the environment in which, the entity exists or functions, that plays a very important role in terms of determining the entity's behavior. Okay, so first thing we have looked at is the characteristics. So characteristics will make the entities unique, and if you combine the characteristics along with the environmental information, you will even get more uh, uh, details or more insights about the data. So, for example, characteristics. So, a particular age group of people in this particular country or in this particular city will behave like this. So, you're getting much more broader insights by combining the environment as well as the characteristics. Okay, so whenever you are collecting the data, it is important for you to check with your business and ask for all this information. Okay, now comes the event. Now, what is event? So I mentioned about the data is nothing but collection of events, right? These are all transactional or the scenarios which have happened, okay, in the past. So these are considered as a business activity in which that entity participates. Okay. So for example, if you are going and making any transactions, so you as a customer of the bank, okay, will be an entity, and you making the transaction will become a event. Transaction will become an event. Where you are making the transaction and all those things will become an environment. Characteristics would be your demographic details, your age, your income group, and all those things will become your characteristics. So here, event is something okay, which would be important for the business to analyze. So if how many transactions my customers are doing, how many purchases my customers are doing, how they are browsing on my website, okay, how many visits they have done, how many calls they have done, okay, all those things are events. By now, we just have kind of captured the environment in which they are staying and the characteristics of those entities, but this is something the activities what they have performed. And these activities, again, very important. So to consider, you will find multiple activities in your data set. The same person will go and log into your website. That is one activity. Again, he will browse through certain pages. That is another activity. He will make the same person making a call to the call center executive. That is another activity. Again, the same guy purchasing a product, a particular product, that could be a one activity. So here you want to finalize what event you want to analyze in your data. So again, accordingly, you have to go and capture or select the data, for that particular analysis. For example, customer. If I want to understand the customer journey, okay, how that person, behaves, and on my website, what he browses, okay, from where he lands up, okay, I want to understand that as a whole. So I'll take all the customers' history, browsing history, and then I will go and analyze. So that is an event which I'm going to analyze. Now, if it is a retail outlet, okay, if I want to analyze how the visits, okay, how many people are visiting to my store, okay, and what they are doing, okay, when they visit. So I can look into those particular kind of events. If it is a call center kind of scenario, there I would like to understand what kind of customers are making what kind of calls, what kind of queries they are coming. So here the problem statements are different. And when the problem statements are changing, then my event, uh, which I need to analyze, would differ, would change. Okay. For the patient doctor visit or for the blood test, okay, for car smog test or comparisons. So these smog test is like, how the car would behave in the smog. Smog is nothing but smoke and fog, okay, together if they're in the environment. How the car would, what is the visibility, okay, in the car. So some kind of a comparison, some kind of a test if I want to perform. Those are the events, which that particular entity has to go through. Okay. And if I want to analyze the outcome of those events, then I will go with this particular information, relevant information. Now comes, now once you analyze, you identify the event, in that event, again it becomes very important like how that entity would behave in that particular event. Every entity would perform differently in different scenarios or different events. What an entity does during an event comes under behavior. Okay. So your behavior would be different on a particular website. Your browsing patterns would be different when compared to other person on the same website. Okay. So that comes under behavior. Okay. So if I have to reach out to customer care, I generally prefer picking up a phone and then making a call. Versus there would be some other person, who would prefer, sending an email or reaching them, through some social media. Okay. So what is the behavior? What is the behavior of the customers, in a particular during an event? That is again something would be a important information. Okay, so for patient, okay, the event is like doctor's visit. Okay, whether the patient is coming because of nausea, because of headache, because of cramps, that is becomes a behavior. Okay, so what was the behavior of the customer or the patient while coming to the hospital or visiting a doctor? Okay, whether they are coming with nausea problem or cramps. So this behavior definition would change with respect to your problem statement. Okay. So the car, when the car is going through the smog test, okay, how it behaved. So did that car skid or what was the acceleration? What was the stopping distance? Okay. Stopping distance is something like when you apply ABS, okay, or brakes, how much far unit will go, when you apply sudden brakes. So what is that stopping distance? So if it is going through some kind of a test, and all these would be behavior. Every car will be showing different behavior, okay, in that particular scenario. Okay. The accelerations could be different, the skid could be different, the stopping distance could be different. So the behavior will play a very important role when when you are analyzing any entity from a business context. So when business will understand, okay, these kind of entities with these kind of characteristics in this particular environment for this particular event would behave like this. Just imagine, okay, if you tie up all these things together and give an proper analysis to your business, the business will get a lot of meaningful information and insights which can be useful for them, to make a better decisions. Right? Now, finally, the outcome. And this is a very important variable when it comes to predictive analytics. So, for example, now the customer is browsing on my website now. Okay, now that is the behavior. Now I want to see what is the outcome of that behavior, whether he will finally buy my product or not, whether he will make some kind of booking or not. That is more important for me. I don't care, whether he'll stay on my website for 1 hour or 10 hours or 5 minutes. I don't care. But for me, revenue is more important from a business point of view. So whether he will make a purchase or not, that is more important. So that can be measured by this particular variable known as outcome. So it is a result of an activity deemed significant by the business. Okay. And these outcome values could be Boolean, yes or no, pass or fail, something like, okay, customer bought the product or not bought the product. He has dropped or he has not dropped. Okay. Or whether the patient has detected with the disease or not detected with the disease. Okay. So it could be just a Boolean yes or no. Okay. And it could be even the outcome could be continuous. Continuous variable means a numerical value. So for example, mileage of the car. If the car is at highway and if it is behaving with a proper with this kind of acceleration, okay, and with this kind of characteristics, then what is the mileage? So here the outcome is the mileage. Okay, continuous. So here, based on the outcome variable, you can decide what kind of predictive model you can train. As this outcome variable is very important and considered as more very significant, for the business. If you train a predictive model to predict this outcome variable, it will give lot of value to the business. If your model can predict whether that customer will buy your product or not, as soon as that customer comes onto your website, okay, and based on his behavior, if my model can predict and give me certain kind of probability, like what is the propensity of that particular customer buying a product, I can go and target those customers. On my website, I'm getting millions of customers every day, but I cannot target every customer because few customers, they are just coming for time pass. Okay, they are just doing some window shopping. They are just browsing just like that. Okay, so I will not concentrate on that. If my model predicts that okay, these are bunch of customers whose propensity to buy is high, their probability is high, I will go and target. How I will target? We have seen one of the use cases. You can offer a quick chat help, personalized chat help. Okay. So that's how you can target those customers. Even in the retail uh, perspective also, sometimes people run a lot of campaigns. Okay. So for example, banks. Okay, you might be witnessing that you may get a lot of calls from the banks for taking certain policies of credit cards or something. How they are targeting. They are not targeting all the customers, like all the people who have the account in the bank, right? So they are picking up certain people. How they are picking? So there is a kind of algorithms are probably based on their experience. Okay, but currently now everything is getting automated, so nobody is using their intelligence, to identify the target customers. So there is an algorithm, which run on the entire customer base, on the entire customer data, and wherever the probability comes high, okay, in terms of how much is their saving account, funds, and based on the kind of services they have taken in the past, okay, based on their income, based on their age and everything, okay, the model will predict that the year is this guy has a higher propensity to buy one more service, or to buy one more credit card. And then these people will start making calls to those people. Okay. So they have a lot of other data also, okay, which they keep acquiring, from multiple sources, okay, to have a complete 360-degree view about their customers. Okay. So the outcome is very, very important for the business, because the business top line and the bottom line is depends on outcome only. How the customers, what customer, how the customer would react, okay, in the end, that is more important. And based on that, they will make the strategic decisions. For example, patient. Okay, so now take the patient. Now here I want to train a model which can predict the blood pressure of the patient. Hypothetically, you just assume about this particular use case, but in reality, no need of having a predictive model. Okay, it's a very simple process, to measure the blood pressure, right? But diabetes could be one of the use case, or detecting, predicting cancer, or predicting some chronic diseases. Okay, could be a valid use case. So depending on the behavior, depending on the characteristics, depending on the environment, all those details, if I capture, okay, I can able to predict, or I can able to train a model which can detect whether the person would get any kind of heart disease, or would get any kind of diabetic diabetes, or he may suffer with any kind of a cancer. Now such kind of models have been developed and are being used now in the hospitals, as well as in certain health related applications. Okay, so it will take all your information, how you're behaving in a day, your body vitals, your age, your everything. Okay, your weight, height, everything it will consider, and it will keep predicting the risk levels. So there are certain applications which are already there. These are all paid applications. So there, the model has been trained, and it will give you an indication like how fit you are, how and how much risk you may have related to your health, say in terms of being diabetic or blood pressure or heart stroke or in terms of stress and all those things. Now you're seeing when you're using a Fitbit, okay, in that Fitbit also it will give you some kind of alerts, right? When the values process a particular levels, okay, it will give you an alert. So like that, there's a lot of solutions are being developed. Even on the car side also, this is an interesting story because even we developed one such solution for one of the automobile manufacturing company. So see now every automobile needs to be tested. Okay. So taking every vehicle outside in the field and testing it, right, multiple problems. There could be a wear and tear. Okay, the tires may get damaged, the vehicles may get damaged. So even the vehicle, lot of dust and all those things, it requires again further cleaning and everything. And again, there is efforts and time consuming, to take every vehicle and getting tested. So what you can do is you can simulate an environment internally where you can uh, run that vehicle, okay, and take all the values, okay, and then pass it to the predictive model. And the predictive model will able to detect or predict whether that car will pass that test or not. What could be the outcome of that particular test the model can predict without taking the car or without taking the vehicle outside into the fields. Now, again, this in automobile industry, these predictive models are being used, for testing the car's performance. Okay, without investing too much of efforts into it. And for whichever cars or whichever vehicles the model predicts the high probability to be which will get passed, confidently they will take that cars and they will give it to showrooms. But for whichever vehicles the model is kind of not sure, the probability is not high or it is too low, those vehicles will be again manually tested. So that's how they are reducing a lot of cost and they are reducing lot of efforts in performing those kind of after building those kind of models. So is this clear? Every attribute so far, whatever discussed, is all attributes clear to everyone? Do you have any questions? Now there is another term, which we more often we use is observations. What is observation? Now observation is a collection of all those things. Okay. So when you are collecting the data, when you are capturing all that information related to a particular customer, okay, a particular patient or particular car ID or vehicle ID in a particular row, then that particular row is considered as an observation. Okay, so it will capture all the information related to entities, related to characteristics, related to environment, behavior, outcome, everything. Okay, so one single row in your consolidated data is considered as an observation. So you can call observation as a system of record. It's a record. If I'm recording, if I'm capturing all the information about a patient in a single row, okay, like that I have captured all the information for 100 customers, then I will be having 100 observations. And those 100 observations, I will use it for my analysis or to train my model. Okay. So observations, nothing but in a table, rows are known as observations. And the columns are known as features or fields. Okay. And together, these observations and fields, rows and columns, is known as data, or we call it as data set. So there is the difference between data and the data set. Can anybody tell me what you think could be the difference between data and data set? Anybody?
Data can be unstructured or structured. It can be in a form of,
Mhm.
audio, video. It can be anything and everything. Here we have like an organized set, which has some relevance or connection between each other. The
Okay.
data sets.
Partially, it's correct. Anybody else? data and data set. And in data science, we generally use data set. Okay. So see, what do you think when we call, set, what do you think it means, set?
A
I think in
pair.
mathematics, you might have studied about set theory and all those things, right? What do you mean set?
The same kind of features which have.
Grouping.
So set, okay, set you can consider as a portion or as a part of a particular overall system. Okay, and the set. So we take, okay, take this set. Take this set means, okay, I'm just taking a particular part of it. Okay, so from entire data, if I'm taking some portion of the data, then that is considered as data set, irrespective of whether it is structured or unstructured, whatever it is. You can call it as a sample. Okay, in simple language, it is a sample. Okay, I'll just change the slide. So basically, a few collection of observations or collection of records, okay, is considered as a data set. So basically, a data set is a data which has all the details which you need to consider for your analysis and which is required, for training a particular model. Okay, and this data set can be structured, can be unstructured, or can be semi-structured. So now choosing a data set is very, very important, guys, in the finally. Okay, because if you look out, whatever we have discussed so far, entity, observations, environment, characteristics, and all those things, there could be huge amount of data which would be stored, right? If you talk about event, just imagine, how much amount of data would be there, if the business is capturing every event of a customer. Would you use all that data for your analysis? Probably not required. Okay. If it is required, then we'll use that all big data tools and technology, but it would be an expensive affair and the costlier affair, right? Firstly, you have to take a call whether you want to perform the analysis on the entire data set or some set of data would be, you know, enough, for your analysis. So now choosing the right data set, right size of data set with the right information and details is very, very important, for making your analysis correct. Otherwise, as I mentioned, right, so if your data is not correct, all your analysis will go wrong. Okay, so choosing the right data set is very important. And data scientists collect and work on data sets to learn about the entities and to predict and to train a predictive model. So we will see, okay, so basically in statistics primarily, all the concepts deal with samples. It's all about sampling. So that's the reason the statistics plays a very critical role when you do not have enough data and you want to do some kind of analysis. So in statistics, we will understand there are various concepts, okay, through which, we can kind of generalize about a particular scenario with limited data, with a smaller sample. Okay, so and when we are getting into machine learning also, we don't take the entire data and train the model because it's, as I mentioned, it is going to be an expensive affair. Okay, just imagine if you can learn a particular concept with 10 or 15 problems. Okay, if I give you 10 to 15 problems as an exercise, to learn that particular concept. If that is enough, what's the point giving 1,000 questions to you and asking you to learn? Okay, firstly it will take a lot of time and there could be high chance that even you may get confused. So here also when I'm training the model, I will not take huge amount of data to train the model. And in the machine learning classes we will talk about one concept known as bias versus variance trade-off. So we have to keep it in mind that my model should not be biased and at the same time there should not be high variance in my model. So we'll understand these two terms. So everything depends on the data, how much data I'm using, to train my model. Okay, so if I take very small data set and that too specific to a particular scenario only, then my model will become biased to only that particular scenario. If I'm taking huge amount of data, then my model will become so vulnerable. Okay, if there is small change in the input, my model will react to this because it will learn too much. So that's the reason we always prefer to go with some some data which is relevant and which is appropriate for my analysis, and that is known as data set. So, for example, for images also, I want to train a face recognition model. Do I need to consider the faces of all the employees which I have in my company? Just I want to have a model which can detect the face, not recognize, but detect the face, whether it is a face or it is not a face. So just models need to understand, how the face looks. Okay, how the face looks, and how it is different than any other object. So for that, I need not to collect the faces of all the employees or all the people, whom I know. Okay, I will just take a small data set. I will take, let's suppose, 50 or 100 people's faces, and then I will give it to the model, and the model will able to understand, okay, how the face looks. Okay, so now that is known as data set, and it differs. Okay, your model accuracy, your it changes based on the kind of model you are using or kind of problem statement you are solving. Based on that, you have to come up with a right level of data set, and there is no thumb rule like for this problem this should be the data set, this should be the size of the data set. It is more iterative. So first, go with a simpler approach. Take a decent amount of data. Okay, train your model. If your model is not able to learn properly, is not giving a better accuracy, then increase the size of the data set. So it is like iteration by iteration. You keep increasing your data set and stop at a place at which you are getting a desired accuracy from your model. Okay, so that's how you have to uh, go ahead. When you are solving any data science problem. Is this clear, guys? And after that, we have discussed about structured, unstructured, semi-structured. So any questions on the data? I hope by now, you have got a good understanding about the data, right? Any questions? So in data science, usually we call, when we talk to each other, we ask like, hey, what data set have you used, to train this model? So data set could be collection of multiple data together. It's a more of a consolidated data which is coming out from various data sources, and you are combining that into one particular format. Okay, that is also called as a data set. And data set is also a combination of certain observations and certain fields which are relevant for your analysis. So this is the whole data which is required for your analysis. Now that is known as data set. And it could be the part of the entire data, what is organization data which is available. It would be just a portion of that data. So that's the reason it is called as a data set. Okay. Now that's about data. To continue, I'll just quickly high level, I'll glance through it. I will not go in detail because this is something, okay, we are going to learn in detail, okay, in the subsequent classes. So now, what is learning? As I mentioned, it is all about discovering knowledge from the data. We know, how to extract the information from the data that everyone being doing in some or the other way, right? When we aggregate the data, when we transform that data into some graphs and charts, okay, we are transforming that data into information. But this is something new you might be hearing that, okay, discovering knowledge from the data. And this is something is done through learning, okay, and that's where these machine learning algorithms comes. Now, for you to understand, how these machine learning algorithms functions, what is this tech model, okay, all about? What is this model? What it has? How it predicts, okay, anything which is unknown to the business. That is something, okay, we are going to discuss now. So basically, this learning, when this learning happens, the algorithm will try to find out the relationship between the variables. If even in our real life, if we understand the relationship. So for example, if this particular event occurs, for example, if there is a thunderstorm, okay, if there are clouds, we can easily predict there is going to rain, right? And we can say it confidently because there is a relationship between those events, the cloud coming and raining. Okay, there is a connection, strong connection relationship between that. So similarly, in the data in the past, historical data, the events, which this algorithm will go through and analyze, through those events, it will understand, which of the events are correlated to each other, which of the variables are highly correlated to each other. So for example, now here we have two attributes, A and B. When A occurs, B also occurs. So for example, when you go to any store, if you buy burger, okay, you also buy French fries. These two events are kind of occurring together many number of times. So when we talk about probabilities and joint probabilities, okay, which we will discuss during the statistic classes, there you will understand, how you can able to find out or these relationship based on, probability or joint probability. Okay. So if there are like continuous variables, like for example, numerical variables, if the temperature is high, okay, then the voltage is also high. Okay. So these are the two numerical variables which are related to each other. If I increase the voltage, my temperature would also increase, or the current would also increase. Okay, so that can be analyzed by, again, there are different measures like correlation analysis in statistics. Through that, we can able to understand. So these algorithms, uh, these are discovered in a way, or these are framed in a way that these algorithm will go deep into the data and can able to identify those kind of relationship. So for example, when A occurs, B does not occur. When A increases, B also increases. When A increases, B decreases, right? So you will find if the price increases, my sales are decreasing. Right? If I'm increasing my discount, my sales are increasing, right? So when I take all this historical data, I can able to this algorithm can able to mine all this information from that data. So first information, which is very important for the machine learning models to identify, is the relationship. Okay. So let's suppose it has identified a relationship, and it can even able to identify relationship between multiple attributes also. For example, when A is present and if B increases, the C will decrease. Okay. So when we are talking about thousands of variables, hundreds of variables, you will find these kind of relationship, complex relationship existing. If the person is male, if his age is below 30 and about 20, then he is very likely to purchase these kind of products. Basically, technical technology gadgets or anything related to latest technology, okay, or drones or something. Okay, so there is a high likelihood that that person will buy that product. Okay, so all that kind of insights will come from the historical data, okay, from the data set which you are using for your analysis. So some examples, as age goes up, spending capacity goes up. How I can make that statement? I will go and analyze these two features, age and revenue. And then I will use some statistical measure on top of it to understand, is there any kind of a relationship between age and revenue? Or else I will go and plot a scatter plot or a graph where I will take age as one of the axes and revenue as one of the axes and see that if there is any kind of a pattern existing. If the age increases, is the revenue also or the salary also increases for a particular person or not? Second example, urban customers buy more internet bandwidth. Sometimes these relationship between the attributes are common sense or it is logical. It comes through experience. It comes through domain understanding, and sometimes you will extract that from the data. Okay, when no one is helping you out in terms of selecting the right features, for your analysis, you go and perform your own analysis, statistical analysis on all those things, and you yourself can able to identify the relevant features which are important, which are highly related to each other. Older patients have more prevalence of diabetes. Okay, this can be proved by using the data. Overweight patients typically have high cholesterol levels. How these, how you are making any kind of inferences like this? It has become common sense now, but somewhere it has been proved, right? And it has been proved by facts and figures and by the relevant data. Then only people are, they have generalized it and they are talking about it, right? So the more cylinders in a car has, okay, the mileage tends to be lower. Okay, it is a proven fact. Okay, if it is a sports car, then you will find more cylinders, but the mileage, it would be too low. Sport cars have more insurance rates. Okay. So these are some of the relationship you might agree, this everyone knows about it. So there's the reason I'm taking a very generic use case examples, but it could be very domain specific examples also. Okay. So in those cases, those kind of insights you can only derive based on the data. And all these findings also have been derived by the data only sometime. But now it has become a universal truth. Okay. Similarly, in the businesses, there would be a lot of relationship which would be hidden inside the data, which you have to mine through by applying some statistical measures on top of that data to derive those kind of meaningful relationship between the attributes. And if once that relationship is being identified, then businesses can make a relevant decisions or meaningful or impactful decisions, which could help them, to improve their businesses, right? Now, when it comes to relationship in your data, it could be a consistent patterns. For example, every time in your data, you are seeing that, okay, let's take one example. Let's take this age and salary. Every time you are seeing that, okay, as the age increasing, the salary increasing for a particular person, for people, okay. But there could be some kind of incidental patterns. Incidental patterns is it can be one time kind of a pattern, okay. And now this is where it will confuse the model. There could be certain instances where the people with a lesser age, with a less age, can draw a more salary. There are certain exceptions, right? So incidental patterns are nothing but considered as an exception. There could be a guy with 22 years age, just after his graduation, he is drawing 1 crore. Okay, so we see those kind of news, right? So those are not consistent patterns. Overall, generally, typically in any population, typically your salary increases, okay, based on the age. Starting your age, your salary could be 6 lakhs, 8 lakhs, and but as you go and reach to 40 years and 50 years, your salary may reach to 50 lakhs or 60 lakhs. But if you see one or two exceptions in your data where the age is 25 or 26 and the salary is 40 lakhs or 50 lakhs, now that is considered as incidental patterns. Now those patterns we consider as a noise because that is something, okay, it will confuse the entire model. Okay, and model will not able to understand, okay, whether age is impacting the salary or not. Okay, if you have that kind of patterns, so we call it as signals and the noise. Signals are something, okay, which are consistent, okay, in your data and which will give lot of information and details to the model or to the algorithm to learn the relationships from the data. And noises is something which will confuse the algorithm, to learn any patterns. Now comes a correlation. Correlation is one statistical measure which will kind of uh, measure the relationship with certain magnitude. Okay. Based on this correlation values, you can able to understand how strong the relationship is there between the variables. So these are some of the important things, okay, you have to remember in your mind when you are commenting anything about the relationship. You have to see that how strong that relationship is, how consistent patterns are there in your data. Is there any kind of incidental patterns or that? Even the incidental patterns also you have to analyze in detail. So whether those incidental patterns you have to retain in your data or you can drop it. Okay. That is also something, you have to take a call based on the business inputs. Now, what is learning? Okay. Learning implies uh, learning about this relationship. So now, once this relationship has been identified or been discovered from the data through these algorithms, now you can use that knowledge, okay, that knowledge, for making some kind of prediction. Now, this whole process is known as learning, okay. It involves domain, definitely, understanding the attributes that represents that domain, collecting that data and understanding the relation. So this is step-by-step process. So definitely uh, when you are considering any business problem, it has to be related to a particular domain. So now I have to choose, what domain, what problem statement you want to solve, right? And then based on that problem statement, you have to go and look out for the attributes. So whatever data elements we have discussed, right? Now you have to go and look out for that kind of information, which could be useful for your analysis. Now go and collect that data and then use the algorithm, and even through statistical techniques, you first go and understand the relationship between those attributes. And then you go and train that model, and then that model would be the outcome of that learning, which can be used, for making the predictions. Now, finally, let's understand how that model looks like. This is one of the example. So for example, now I want to train a model which can predict the blood pressure. And I want to use certain attributes which could help me to predict the blood pressure. And we everyone of us, we know that, okay, age, weight, this LDL, okay, which is a medical term, is directly related to BP. If somebody is of uh, higher age, okay, they will be more prone to having high BP, right? Even the weight will play a critical role. LDL is, I think, it is related to cholesterol and all. Okay, so if there is a high cholesterol, definitely there is a high chance of BP, right? So we know about it. But how they are related, how much weight can be assigned to each of these parameters, that we don't know. We generally say that, okay, yeah, higher weight, higher BP. But what is that weight? Can you quantify it? And if this much is the weight, then how much is the chance of having this much amount of BP, right? So that is like become a very uh, complicated situation, right? So I can take all these attributes and I will feed it to the algorithm. Algorithm will identify the relationship and even it will quantify that relationship, how that relationship is all about. And it can give you a equation like this. So which is a very linear equation. But when we talk about multiple other algorithms, sophisticated algorithms, they are even they are they can able to detect the nonlinear relationship also. Let's suppose now there is one algorithm which has given me this kind of equation. Now this will become my model. So if I know the age of the customer, weight of the customer, and LDL of the customer, or any three parameters, if I know through this particular equation, I can able to predict the fourth attribute. I'll just substitute the values into this equation and I can able to predict. Now this is nothing but a model. When I'm saying model every time, predictive model and all through, this is nothing but it is a kind of representation which will represent the relationship between the variables. Here I have shown you only one single representation, which is in the form of equation. But when we talk about various other algorithms, the representation would be even different. There is certain tree models. There the relationship will be represented in the form of tree, not an equation. So like that, we have different, I call it as a flavor of algorithms, and where you will get different representation of the models. Okay, but consider this as just an example. Okay, For example, this could be, you can relate with kind of a tree map. Okay. If the age is less than 25 and if the customer is a male, then buying a particular product would be high.
Shrikant, I have a question. What is the difference between model and algorithm?
Sorry, what was your question? Can you repeat?
What is the difference between model and algorithm?
See, algorithm is a step-by-step process and approach. Okay. So it is a programmatical way of representing that full approach. When you feed that data, algorithm will go systematically and step by step, that it will follow that approach, okay, on that particular data. What it will do, it will identify the relationship, it will quantify that relationship, everything, will be written in that algorithm. Okay, it will go and follow that particular path. And once it has identified all that, quantified that relationship, then final output is known as model, which could be in this form. Okay. So we use algorithm and then train that algorithm. And once the algorithm is learned, then the output is known as model. And that model, we can use it for predictions.
Okay.
Got it? Okay.
So can we say that, a square plus b square is equals to 2ab? That would be the model. And the
Yes.
working of how we got it would
How we
be
derive to that equation,
yeah,
that is an
the
algorithm.
algorithm, right?
That is an algorithm.
Okay.
Yes. Okay, so accuracy of the model depends on the strength of the relationship. If you find consistent patterns, then there would be a strong relationship, and even your model accuracy would be better. If there's a lot of incidental patterns are also there existing in the data, then the relationship would not that strong. If you see that, okay, if I take again rain and cloud scenario, if you find more number of times, even if it is a sunny day, still it is raining. We have seen, right, those kind of scenarios also. Even there is a sun and still it rains, right? If you get those kind of patterns more often, then the relationship between the cloud and the rain, will go away. Okay, it will get diluted, right? The strength of that relationship will be not that strong. So similarly, in any kind of a data, okay, if there are incidental patterns will start dominating, then your relationship will fade out. Okay. So wherever there is a strong, consistent patterns, the relationship will be strong. If the relationship is strong, then the predictions could be stronger, right? And the model accuracy would be strong. If you see that always there is a cloud, there is a rain. If always there is a cloud, there is a rain. So very strongly, very confidently, you can predict, okay, it's going to rain if you see the cloud, right? Similarly, here in this machine learning space also, it happens the same. So yeah, so once the model is trained, you get this equation. Now you can use it for prediction. So if you know any three of those four attributes are known, the fourth can be predicted. Okay. Yeah, so I will take another two slides and then I'll stop. Okay. So I'll take this example. So by now we have discussed, right, what are the different attributes of data. So let's suppose I'm talking about some kind of an outcome. Okay. So this is my entity, customer, patient, and car. These are my all characteristics and behavior related data. Let's suppose I'm taking age, income range, and the location as one of my predictors, which we also call as features. And this is my outcome, or we call as output variable or target variable. So now based on these features of this particular entity, I want to predict this particular variable, which is my outcome. So whether the person will buy or not. Based on the age, income range, and the location, I want to predict whether the customer will buy my product or not. Based on the patient's attributes like age, blood pressure, and the weight, I want to predict whether that person is prone to have diabetes or not. Okay. Based on the car's attributes like cylinder or acceleration, I want to classify that car as a sports car or a family car. So now this whole predictive analytics depends on only these two set of variables. One is the predictors and second is the target column, okay, target variable or the output variable. Okay, so now when you are solving any problem statement, you have to clearly define what is your output variable, what are your input variable, and then accordingly you have to choose the algorithm and you have to train the model. So that whole process is comes under learning. Now, by now you can able to understand, how these predictive models would be helpful. Okay. See, now it is a comparison between the humans and the machines. Humans understand the relationship like in our daily lives. Okay, we understand a lot of relationship. Okay, lot of relationships, like, okay, even if somebody behaves, we understand why that person is behaving, right? We understand, okay, this might have happened, that's the reason this guy is behaving like this, okay, cranky, okay. So, or probably, he has not got his breakfast, that's the reason he is behaving like this. So like that, in our surroundings, in our environment, in our daily life, we kind of understand, like, these kind of relationship between the events. Okay, and we keep predicting all the time. Okay, so now, but there is a problem. We as a humans, okay, we can only handle finite amount of data because we take a lot of inputs from our surroundings, because through our sense organs, like what we see, what we hear, what we talk, okay, what we perceive, okay. So all, so lot of inputs every daily. Just imagine, how many input we are receiving, our brains are receiving. Okay, now while I'm talking, a lot of other things also going into my brain, okay, based on what I'm seeing, okay, based on my memory, based on my future commitments, everything also simultaneously running in my brain. So, but we have a limitation. We cannot handle infinite amount of data. Whatever is recent, whatever is in present, okay, that only we can able to keep it in our mind. So, for example, one shopkeeper can know the preferences of maximum 100 customers. Now, when you go to the Kirana store nearby your home, there you will see the shopkeeper, they are very intelligent. Okay, as soon as any customer comes who is a regular customer, okay, they can easily go and say that, okay, do you want this? Are you forgetting this? You usually buy this, right? Don't you want this item today? Okay, because he can remember, but he can remember to certain limit only. He cannot remember, if he's doing business with 10 millions of customer, 10 million customers. Okay, he cannot remember all the 10 million customers' preferences. That's a challenge, okay, with the humans. But with the machines, it's possible. Okay, I can take a very sophisticated machine, okay, with a high memory, okay, with high processing speed, all that thing can be remembered. And I will go and consider some very sophisticated algorithm which can mine through that huge amount of data, can able to extract the information. So that's where this machine learning, this predictive analytics, and this data science is playing a very important role, because it is beyond human ability, and there is a limitation with humans where, these machines are kind of playing a better role than compared to humans. And that's how, this businesses and all these people, they are adopting this data science and machine learning nowadays. Okay, so with that, I will stop today's class. And from tomorrow, you will get into Python. Okay, so these are just the basic things, okay, which we have discussed at a high level, so that you get a good understanding about this overall space of data science. From tomorrow, or probably tomorrow only, otherwise, maybe day after tomorrow, the Python classes will start, and there would be another co-trainer, okay, Vikrant, who is my colleague in my current company. Okay, he's going to take care. He will be covering that Python classes. He's a completely, uh, he's like tech savvy. Okay, he understands a lot of programming languages. He's one of the best programmer I have in my team. So instead of me, I felt that if he explains you that programming, it would be better. Okay, so because he's hands-on, he's currently working on the projects. Okay, he's building different innovative solutions. Okay, so he will be taking that Python classes, and from the basics, he will teach you the programming aspect. And whatever questions you have, please feel free to ask him. Okay, and we will also uh, create one Telegram channel where all of you, whoever has enrolled, will be added to that particular channel. Okay, so all the communications, everything, the sharing of the material and the course and source codes, everything, will be done on that particular channel. So take a call the people who have not yet decided to whether to enroll for this course or not. Please take the decision today and let us know so that we will go ahead and add to that particular channel. And tomorrow's class, the people only whoever have enrolled, they can only attend from tomorrow. Okay, so these are more of a demo classes. Okay, and from tomorrow, the only people who have seriously enrolled for this course will be able to attend the class. All right, so any questions? Yeah, Amrita.
Can you give me a quick glance about the signal, noise, and correlation? I have a little doubts there.
Okay.
Uh,
Okay.
So
So
understand that noise is something that is like more of an incidental pattern that appears.
incidental patterns, those are
Yeah.
not. Yeah.
What about signals? Is it like
Signals are nothing but the consistency.
that's it,
How
right?
you how you how you so basically how you literally understand the signal and noise. Signal is something what we consider something a meaningful information, right? We
Okay.
we call signal which
It's
are
a
like meaningful
continuous wavelength. It has a pattern, basically.
Yes, yes.
Right?
So signals are something a good information which is helpful for the model to identify the relationship. Noise is something which will distract this model to identify the relationship. So in the
Okay.
data, we will have to deal with both signals and noise. And
Yeah.
when we talk about machine learning, we will also understand, how to deal with noise, in the data.
So since consistent and incidental pattern and signal and noise are quite similar, I'm not saying same. Why do you have those two like separately? Why we are talking about?
No, I'm not separately talking. I'm just telling you, okay, I'm comparing these two things. So
Acha.
data science, sometimes people may talk about signal and noise. Sometimes they may talk like consistent and incidental
Okay.
patterns. So you need to understand, okay, these are all the jargons
Yes.
which you have to play with, right? Yeah. Yeah.
All right. What
Yeah.
about these correlations? Does it
Correlation,
depend?
yeah, correlation is a measure which can help you to quantify that relationship.
Little layman terms, please.
Quantify in the sense, okay, I will say that, okay, this temperature and voltage, the correlation
Direct,
between those two variable
proportional.
is 0.9. So here I'm quantifying. So correlation, when we discuss in statistics, it will range between -1 to +1. If the values are closer to +1, that means they are positively correlated. If it is towards -1, then they are negatively correlated. So
It's
negatively
like the
correlated means inversely.
compatibility is less, or we don't have to consider it. Is it like that?
Yes, yes. So either you can look at the patterns in the data and you can comment about it whether there is any kind of relationship, or else you can use some kind of a correlation techniques, okay, or methods to quantify the relationship between the variables.
Okay.
So it's all about identifying the relationship. I mentioned, these are the different uh, areas which you have to look into, to identify the relationship.
Okay.
Look out for consistent patterns and see that if as an example I mentioned, if the two events are occurring more number of time consistently,
Yeah.
so based on those events, you can consider that those events are highly correlated. If you want to
Okay.
go with a scientific technique or method, then you can use this correlation analysis and all those things to identify the relationship.
Okay.
Okay.
Yeah.
Any other questions? All right, guys, then thank you.
Thank you.
Take care. Bye bye.